So welcome to Finding Focus. This is a channel where we build a game from scratch using Love 2D and Lua. Now we're building a Link's Awakening style top-down adventure game, and today we're going to be focusing on rendering our players' entity states. So yesterday we got our entity state figured out for the character. So if you just glance at it here, it looks like we didn't get anything done from the last 2 days, but we are now rendering our character solely from an entity system. So if we take a look at what our character's code actually is right now, get a little comfy here. Okay, if we take a look, we're initializing our player as a player with inheriting these entity defs, which is just where we define things like an animation and a walk speed. So if we take a look at our player class, you'll actually see our whole player class is now 24 lines. It used to be, I'll show you, all of this. So it was about 357 lines minus the 24. Now we do have to change some stuff because we don't have all the functionality we used to have, and I'll show you what that is. If we hold conflicting left and right movements, it just picks a direction. It goes with the last direction. So we have to decide if that's something we want. The other thing is, if we initialize a direction going left, then we hold up, it doesn't go up. It kind of prioritizes the only thing that's held down. So it's ultimately up to us how we want to do it. Now, before we put in our entity system, I actually had it so that I was overriding the directions. So like whatever the last input was, that became the direction and the movement we got. And at the moment, we don't have any diagonal direction movements. So we need to add that. Right now, what's happening is anytime the button is pressed, we're assigning a new state. And that state, well, actually, I think it's just assigning a direction for the entity. And the update for the positioning of our character is linked to that direction that the entity is facing, and as well as the movement update. So we need to slightly change that so that anytime a direction is held, anytime a left direction is held, we're subtracting from our left velocity or our current left position. Anytime right is held, we're adding our walk speed to our right position, to our current position, and then we have to re-implement our normalized vector for our diagonal movements, because right now we don't have any. So we have to allow that, and then we have to change our sprite based on the last input. So that's part of the 300 lines that we missed out here. So our current player class is only 26 lines, but it used to be 350 or 325. So we need to do that. And then also what happens now too is we can walk right off and it doesn't do anything. So we have to reinitialize our scene changes based on our player's X position, and then we'll be back where we started, which is actually we're in a much better place because we'll have a whole entity system. So if we want to add where Kuvo's holding an item and he needs to change sprites, he can keep all of his movement data, but he's just going to be updating some sprites. And then once we add collision detection for entities, I think we've got basic AABB collision in there right now, but he'll kind of have access to all that stuff. So it is a big step forward in the long-term development of the game. So it was a lot of work. I think yesterday was about 3 hours to get that just implemented after I wrote it all. So it took me a while to figure it out. but we'll see if we can figure out, we can see how this is somewhat implemented. So first of all, I want to take a look at our animation class because that handles all our rendering. So it's got frames, an interval, and a texture. And in the update for the animation, we're just looping through the frames and we're setting our current frame anytime our timer is past our interval. So it's just looping our frame back to 1, looping through all our frames, and then looping back to 1. Now, if we take a look at our entity defs, it's just a bunch of data here. So we've got a player key that has a walk speed and animations field, and then we're initializing animations to be equal to a table of keys that all have appropriate texture, intervals, and frames. So that's how we control what frames we're rendering and how fast we're rendering it throughout our walking animations. So what we have to do, it's not that we have to add a walking diagonally up and to the left state. It's not that we have to do that. It's just that we have to make sure we only inherit the walking direction that we want depending on our last input. So we'll have to keep track of that once again, like we used to. So let's see in our play state where we're actually kind of giving us the player. We give us the player right here, and we manually kind of instantiate it there. And then we don't render the player here or update the player. We used to update the player here, but now we are doing it, I believe, in our scene. So if we go to our scene here, we can see that let's see, that's all our triggering, our scene transition triggering is all there. Okay, so maybe we are, we are we're updating our player here in our scene, and we're ultimately rendering our player here in our scene. So we need to figure out, hey, Leva. Hey, cool, man. Good to see you. Yeah, it's funny because like the last episode, we undid basically all our working diagonal walking and all our scene transitions, but we've now got it working in an entity system, so it should be a lot cleaner. So I'm hoping it'll be a lot cleaner. And it's looking to be. We just got to re-implement some stuff we took out. So that's what we're working on today. Hoping to get our character back to what it used to be. Like, look how messy this is. We used to just draw the appropriate quad of our atlas depending on what frame we're at. So every single frame we were asking what frame it was, manually assigned. We do need to do something like this again, where we need to get the last input held, and then we need to redo some stuff like this. So if we look at, now we had if inputs is held down as 1, then if we hold right, we know we're moving right. I'm not so sure that's a great way to do it. We've got and then we're kind of like explicitly doing things here, like if up and right is held down, then we're making sure only 2 directions are held down, because we had some bug where if you hold down all 3 directions, it wouldn't actually move, but it really should just move based on the last input. So we're gonna have to redo that. Then we're normalizing our vectors for diagonal movement, which we gotta re-implement. So I guess the question is, how do we do it differently now that we've done it once? And how do we do it slightly better, slightly cleaner? Because look at how, anytime we would hold down our input, we would manually assign these booleans, and then manually flush those booleans. So we shouldn't be doing that. I guess let's thanks for chatting for the first time, Leva. I appreciate it. It's cool to see you here. I think the first move is to just change our animation state based on our last input. So we should, if we take a look at our at our entity update, see it's so bare bones now, this whole class for our player, because all we're doing is updating our entity. So it's going to be tricky since the player is the only entity that directly reacts to our keyboard input. We might have to get a little clever here, but I don't know exactly what that entails. Let's see our entity class here so we can make sure. See, so we've got a direction, a bunch of animations, an X position, a Y position, an offset for rendering. We've got this create animations function, which just assigns all the animations from our entity definitions. And then this is where we're handling the state change. And then we don't have an AI to process just yet. I mean, that's mainly for our other bad guys and stuff. So like we'll add a spider at some point or a gecko at some point. But right now we're trying to get our player back to where we used to have it. So this part is kind of interesting. This is how the CS50 did it. The CS50 example. We've been comparing our game to this game to learn how to do these scene changes and entity system, because our game is a lot similar to this in a lot of ways. We're not doing random map generation. We are doing some manual kind of level design stuff, but that has the whole entity system. So that's where I got a lot of these techniques from. It's from that Colton Ogden repo, and they do this where they modify their X position by their offset, then they render, and then they go and set their X and Y back to their original position. So I thought that was kind of weird. But I think it fixes the problem that we had with our animations not being able to come on from the next screen as we initiate that transition. So one question I've got is, how do we define and where do we define our player movements? Like where do we change our animation to our walk state and everything? So like we search for walk state. We don't have walk state. Maybe it's called direction. So we can just search for any time we mention direction, and we can see where we change right there. So in the player walk state. Okay, so in our player walk state, that's how we kind of decouple. Yeah, so The Name of the Wind is a fantasy book that came out in like 2008 or something. It's supposed to be a trilogy. There's 2 out right now, and I really love those books. Everyone's waiting for the 3rd book, but it's one of my favorites, and I thought it would be a cool world to kind of explore for making a game, because there's a whole bunch of magic stuff, exploration stuff. I thought there was pretty ripe with things to do. I actually did if I detach here, I can go and show you. I have a repo called TAC, and TAC is a game that's from the book. It is it's a physical board game that was in the book, but then the author teamed up with a real game designer and they made TAC into a real game. So I had some real rules to kind of look at, and so I made the game TAC from the real game, and then that was my first kind of project like this. And then I wanted to kind of make a project that could maybe implement this game as well. Like we might be able to walk into a pub in our top-down game and sit down and play somebody in TAC. because I thought that might be kind of cool. So like we might be implementing this game within our game at some point, because we've got it already made, and it doesn't fit the art style, but it's another game from the actual book that I thought could be cool. So there are going to be a bunch of little mini games in this game, and I was thinking maybe tack would be one of them. You would sit at the table there in the tavern and play someone in tack. I mean, it's a two-player game, but right now, you know, I don't have an AI to play it. That's too much out of my skill set, but I just thought it'd be fun. Okay, so our entity walk state here, or our player walk state, is where we're actually doing our directions. So I think what we need to do here is keep track of our most recent input here, and then change our animation to be that latest input. Now, we're also changing our direction, and our direction is what's actually affecting our position. So if we would look, I believe if we would look at our entity, we've got a direction. Maybe it's not in our entity. Where is it? Want to find where we're modifying our X position based on our direction. And it might be here. It wouldn't be there. Sorry. I'm just trying to remember where that is. Because we split the old way we did things and moved it into this. Oh, it literally is. We literally just do it here in the update for our entity walk state or our player walk state. So, well, actually, no, it is in our entity walk state. So our player walk state inherits this entity walk state. So if the direction, depending on what the direction is, that's how we're modifying our X and Y position. So that's the thing that we want to decouple. We don't want we want to be able to have diagonal inputs. So we need to modify our X and Y position of our player, not based on just our direction, but based on the two inputs that are held most recently. I think that's what we want to do. So I'm not exactly sure where to start with that, because our player walk state inherits this entity walk state. So maybe we don't inherit the entity walk state, which means we'd have to, let's take a look at our player walk state and make sure. Because yeah, see, we don't even have a render function for this, but we do update it with our entity walk state, and we include it right there, so it kind of inherits all that stuff. So I think we want to decouple this somehow. So we're probably gonna do, yeah, I want to say that we stop inheriting the entity walk state, and we instead have a player. Our player walk state is just going to manually get all that stuff. So if we don't update the entity walk state, and this, I guess this player walk state wouldn't include anything because we're not trying to inherit any of that stuff, then we would need a render function for our player walk state. And before I do this, I'm just going to think a bit and make sure that this is what we want to do. Because if we don't have our player inherit our entity walk state, that it doesn't change a whole bunch of stuff. It really doesn't change a bunch of stuff because we don't need this movement duration or movement timer. We do want a reference to the current entity that we are and the scene we're in. And it looks like we do need to include this base state so that we can use state machines to change state like this. So I think we do need to do that actually. So we'll go ahead and do that. We'll go class includes base state, and then we also need to now we do have a player being passed in, which I guess makes sense because only a player should be passed into this player walk state instead of an entity. So maybe we'll say self.player now that we've got that. And we don't have to manually do this. We can go highlight all of this stuff and say substitute entity with player. And then we're good there. We just need our render function, which needs to render the appropriate global texture and global quad for our player. So we will go into our entity walk state and take a look at our render. And what we're doing here is we save our player's current animation as a variable, and we're gonna then draw from our atlas, which is from our global textures table, at our texture of our player. It's our current animation actually, and then we're gonna be drawing it at the quad of that animation of the same name at the get current frame. Okay, so it's a little tricky to kind of break that apart. I think the anim.texture, the current animation, this dot current animation is from our entity defs. So if we look at our entity defs, we've got, and actually it's not from our entity defs, but after we pass it into our animation table, it spits out a field called animations. Does it not? Where? No. Okay, so I guess all it does is let me make sure I'm understanding this, because we've got so get current frame, which we do call, is just indexing our frames at our current frame. So that's just literally just get current frame. It's abstracted away. And then when we do call an animation class. I'm curious when we call an animation class on this. Do we do that? Where do we do that? In our play state? No, we don't do it. So where do we... I want to see where we're assigning this animation object so we can take a look at its texture. Oh, in our entity. Yep, it's in our entity. Okay. So in our entity, we create animations, and this is where we pass in. This is where we pass in the animation field from our entity def. And then what this does is it goes through every set of animations and it puts it into this animations returned variable. and that's what we're assigning to be our new dot animations. So yeah, I don't exactly remember what the pushing 3 arrows did. It either didn't move us at all, or it moved us in a, I don't remember what it did. It was just wrong. I think it didn't move us at all when it should have prioritized the last movement inputted. And that's a total choice just for the game. I've been making a lot of my decisions based off how Link's Awakening actually works. And in there, we actually do it a little differently. Link's Awakening, you can kind of strafe. So, oh well, we're broken right now. In Link's Awakening, you can strafe. So like if you initialize walking up and then you hit right, you kind of strafe but still face up. You can keep walking up and move left and right while still facing up and walking up. So that's how they do it, and it makes a lot of sense because when you have a shield, you want to be able to traverse while still holding your shield in front of you. So in Link's Awakening, that makes a lot of sense. In my game, I'm thinking, and I liked it better when we we changed the direction they were walking based on the last input. So you are able to move diagonal, but instead of Link's Awakening where you would keep your first movement facing direction, we would actually change directions to be the last button you pressed. So I think I like that better because in our game it's gonna have to do with like some spell casting stuff. And I feel like if we have it where we can turn like that, we can kind of aim spells in a way that isn't possible to us if we only have that strafing motion, because we don't have a shield like Link's Awakening has. So that's kind of my thought process behind that, but we have to figure it out. So this is what was confusing to me, because our entity.animations gets overwritten with all of the animation renders. So like this animation class takes in the texture frames and intervals, it'll spit out once we update this entity, it'll spit out the current frame for the animation given the intervals that we give it. So we're overriding those entity defs dot animations with this create animations function. So that's what was kind of throwing me off when I was looking at this player walk state, because this anim.texture is actually the player at the current animation. And if we take a look at, gosh, yeah, because I'm still even a little lost. If we go to our entity, our current animation is not even being assigned. Yes, it is. It's being assigned to be whatever our state machine changed it to. Okay. Yeah, I'm getting a little confused now. It's hard to name these things and keep them separate. Okay, so I'm curious what our dot current animation actually is, because I don't see a dot current animation. Is that part of our animation class that we just don't manually instantiate? Let's see. We've got animation. We've got a current frame, but not a current animation. So I'm curious where our current animation is actually being assigned. It really is just assigned when we change animation. So current animation is a reference to the state machine at the animation at the name field. So we've got, so our current animation is just whatever, it sounds so silly to say, but literally the current animation. And the current animation is defined here. Walk left is an animation, walk right is an animation, walk up is an animation, and we use the get animations function to populate all of these into actual items that'll spit out the current frame. And some of these, like idle is just 1 frame, so it doesn't need to change. So we don't really need an interval for idle down because it's only 1 frame. So that's unnecessary. But now that we kind of wrapped our head around that, we can see that we're drawing our global texture at our anim texture, and our anim is whatever our current animation is. So if we're in walk left, it'll be drawing from the walk left texture, which is separated into quads, and we give it the same name, walk left quads, at our G frames index. So it'll be and then at the current frame. So it's just what frame of animation are we on, in which quad of the animation, in which atlas, or in which animation state we're actually in. Okay, hopefully that makes some sense. I think that makes sense to me. It's just so hard when you abstract all these things away to realize what's going under the hood, because everything's talking to one another. Now, we do need to update our player walk state, which we are not doing. We deferred it to this entity walk state update, so we need to update our player walk state. So where do we update our entity walk state? Let's take a look. We've got an entity walk state update that just has all of that stuff. So where do we update this entity walk state? It's probably in our entity update. We update the state machine. Okay. This isn't what I'm looking for. So our entity, this is so hard to wrap my head around. I've never done the entity system in a game. So it's tough for me to wrap my head around it. Okay, so the state machine update is gonna be updating whatever state our entity is in. So since our player is an entity, you know what? I think we can keep our... Let me see if we go back to our player walk state. Oh, see, and we don't want to... Maybe we just update our entity here. Nope. Okay, I'm not sure where we're exactly crashing. We're not actually... We are changing our direction still, but I don't believe we're updating. We're not updating this player walk state. And we should be changing to it based on our idle state, our player idle state. So we do change into the walk state from player, and that's where we're crashing. So it looks like we're not changing state correctly. Let me see. We crash at state machine 52 Caldman. Okay, so we don't have access to this walk state for some reason. Let me see if going back to our walk state... Oh, well, first of all, we called this Bast state, which is funny enough because Bast is actually a character in The Name of the Wind. Okay. So we're updating our animations. We are no longer updating our positions because that was handled by our entity class. So that's what we're looking for. We just want to redo this. So now we've got those decoupled. So now we should be able to, in this line, this entity walk state update was just a way for us to incorporate all the entity walk state update functions and apply it here. And we don't need that. We don't need that, but we do need to add in our directions. So if we were to just copy and paste from our entity walk state into our player walk state, and we should do this after we get the direction, then now we should move. But I just realized that we're rendering based on our entity, and we need to go switch out our entity for our player here. And then do it globally. Cool. So now our player walk state is decoupled from our entity walk state. So now we should be able to change only our player's direction, and still we want to be able to still have our entities controlled by the direction, because it's nice to say for the AI of our other entities, let's say we have a spider on screen, we can say, hey, change your spider's direction to left, and then it'll automatically start walking left, because walk left means move left, or direction equals left means move left. We just want us to be different, because if we're facing left, we could be moving diagonal left, because if we press up then left, we're going to be facing left, but we need to be moving diagonally up, which means we need to normalize our vector. So that's what we're going to be getting around to right now. I think what we want to do is get the last direction input held. So I think we need to check for was pressed, and anytime like we have a last input, we can just call it last input gets nil off the bat, and actually we can start it down actually, just because if we try to index a nil, we're gonna crash. And then we can have our last inputs. If our love.keyboard, this is how you check for key detection in love 2D, we say is down, and then we give it the key to check. If left, and we don't want is down, that's continuous input. We want was pressed. So, and actually our was pressed, actually I don't think comes with Lua right off the bat. It has, oh no, it does. It does. Keys pressed is what I was thinking of. We've got a little function here to handle our escape or sort of deal. So forget what I said about that. We've got if love.keyboard was pressed as left, then we're gonna want to overwrite our last input with the left string. And then basically if whatever key is pressed, we're going to be overriding our love.press. Now, the order we do this in actually kind of determines what we kind of prioritize in terms of what our last input is. If you technically hold all the buttons at once, whatever the last thing we put in this if condition is going to be defaulted to be that last input. But if the player's just slamming down all the keys, then we don't really care that their input isn't registered perfectly. Like, we want them to play nice. We're just trying to just handle the most case scenario, which is if you press up and hold up, then you press left. We want to still be able to we want to be able to move diagonally. So we're going to go ahead and assign up to our last input there, and then the last, and we need else if for all these. Else if love.keyboard dot was pressed down, get, then we need to assign our last input as down. So we need to do this a little differently. We don't want to be moving us based on our direction anymore. We just want to change our animation based on direction. So now what we're going to be doing is we have to handle our multiple inputs so that and the whole deal with this is if you walk right, and let's say our velocity is 1, over time you'll walk at a speed of 1, and if you walk up, it's a speed of 1. But if you hold both, you'll be walking up and right at the speed of 1, which actually multiplies your vector by 1.4, actually by root 2. So what we need to do is negate that so that we don't move 1.4 times faster when we're walking diagonally. It's just one of those math things that we have to handle. But we'll be doing that here. Else if love.keyboard is right, else if love.keyboard is up. Okay, so now we should have our last input held, which that is going to trigger that. Since our last input, we don't want to check for continuous input. Actually, yeah, we do, because we need to check for continuous input because we need to know whether or not we're animating our change animation or if we're going to go to idle. So we do have to check for continuous input, but we need to only change our animation if our last input is equal to the appropriate input. Is that right? So we'll be changing our animation here. If our last input is left, go ahead, change it to left. Okay, because if we start walking left, then hold up, we don't want to be a change animation walk left. We want to override it with up, which since our up was pressed second, our last input would be up. Therefore, we would change our animation to walk up instead. So I think that's right. So we can keep our direction, and actually our direction, since our direction is only actually modifying our vector here. And actually, no, let's keep direction for now, because we can kind of use. I'm curious what happens if nothing is pressed. What is our direction? So maybe we can print up what our direction is. Let's try to do that. Love.graphics.print, and we want to print the direction of our character. So we'll give us a string, and we'll concatenate that with a stringified version of our self.player.direction. And then we need to give a couple more arguments. We need to give an x and a y, which I'll just put at 5 and 5. And that would hopefully render our direction on screen. So it looks like direction doesn't even populate unless, oh gosh, unless it's, unless something's being held down. So I guess I'm kind of confused on why that's the case. That's good, but I'm not sure why that's happening. Oh, it's because we, well, yeah. So like, if left is held down, we're setting it to left. So maybe in our entity update function, we're flushing that direction or something. So I'm kind of curious why that's happening, because you would think that it would just stay the last direction. We want to see where we modify our direction to be either... What? We don't want... I'm not searching for entity, I'm searching for direction. Direction. I don't see where we're kind of flushing that. And this is one of those things where it's like, it doesn't really matter that it's working right, but I want to know why it's only populating when we press it and why it's going away when it's not. We're not... And you know what? It might be because we've got it in our walk state, that we only update our walk state if we're in walk state, not in idle state. So that's probably it, actually. So if we take that debug out of here, which... Why? Oh, yep, that was my bad. We're gonna go to player walk state and take our debug line out. Okay. And entity walk state, I messed up when I was in there. Dude, what did I do wrong? Love.graphics, entity. Dude, what did I just mess up on accident? Oh, it works now. Okay. Whatever. Okay, we want to render this player not in our entity walk state because only our entity walk state is actually updating. So that makes a lot of sense. So if we go to our play state here, or our scene even, we can go to our scene and we can render that direction. Now we can do the same exact thing because we have a reference to our entity. Yeah. Okay, this is what I thought would happen, which is it would just remember its last direction facing. We aren't changing our state machine for our left direction because we're still riding it, but let's keep going here. So if left is down and our last input is left, go ahead and change animation to walk left. Now why does that oh, do you see there? We render our animation there walking left, but we didn't start walking left. That's the toughest thing about programming, is like when you can't replicate the bug. See, like that, we're not walking left there, but now it's fine. Okay, so I think we just need to continue this on, and we'll make sure that we only change our walking right animation if our last input is in fact right. And then, oh my god, okay. And then same with everything else. Okay. Oh. Okay. Still getting used to NeoVim. I'm trying to be better at it. It's tough though. Like, what's the way we can add the end there and then yank? We can delete this, paste it, and... Okay, so we're only changing our animation if our last input corresponds to that animation. So when we're walking, see, that's not right. Okay, not right. I think we're still... Okay, totally wrong. Okay, it looks like, and here's the weird thing, is we don't want to update our X and Y position based on our direction. We want to do it, so yeah, I'm definitely a hobbyist programmer. I don't have a computer science degree. I'm not very particularly good at it just yet. I've been teaching myself, and, you know, with online resources. I don't know if I'd like it to be my full-time job, but I'm just a hobbyist and I want to make cool things, so I'm trying to make stuff. But yeah, what about you? Do you do any programmer stuff? I think I want to see if our last input is... Okay, I'm not sure what VBA codes are. Okay, okay, nice. Okay, that's cool. Yeah, I've done a little bit of stuff with some macros, mostly in Vim, to run like bash scripts and stuff for me, but not anything crazy. I want to print up the last input direction to make sure we're actually doing this right. So I'm actually gonna turn this into a field within our object here, and we're gonna go, okay, nice, yeah. What did you do with Fortran? I know that was kind of one of the earlier programming languages. That's cool. Yeah, it was. How'd you like C++? Was it is it gross? Or like I've looked at some C++ stuff and I'm like, why is it like this? Why is this so hard to understand? Like, it's definitely not what I'd recommend learning programming with. Okay, we've got this last input. We want to go... Yeah, see, I think that's the wrong move. I think if you say welcome to programming and chuck them C++, it's just gonna hurt people's feelings or hurt people's motivation to actually learn programming, because it doesn't have to be that unfun. We're looking for last input, and we're gonna overwrite it with a self.last input. Okay, and then we want to render our last input on screen. So we're going to render our last input here on screen, make sure that's functioning right, because that's the only thing I could think of that could be screwing us up so bad. So this is in Lua. So it's a scripting language. It's very straightforward. Like, you can tell the syntax is just super easy to read and clean. I hear people talk bad about it, and I don't know enough why. I know NeoVim uses Lua as configuration, but I just love how, and then, so like this stuff like love.graphics.print, that's not inherent to Lua. It's just how the game engine lets you do it. But if you want to print something, love.graphics.print, it's like that, and print something to the screen, and it handles the frame rate for you. It's got Love2D is really cool because it handles a lot of stuff for you. Like, see the FPS in the bottom left there? Last input. Okay, so we need to change this to be last input. But yeah, I'd recommend, I like Lua, even if you're just messing around in it. See, look at our last input is just not being updated. What's going on? Wasn't it working though? Wasn't it just... I thought we saw it working. Okay. This is game dev for you. It sucks that we kind of have to redo all of this, but in the long run, it's going to be so much more scalable. Not our yeah, our last input, self.last input gets down, up, and we don't even initialize this to nil, so why is it becoming nil? It's it's part of our walk state is what it is. So what we could do is instead put it as our player. Okay, let's try this. We change our player's last input. So we want to find any substitute our self.last input. Okay, how did I screw this up? We're changing any self.last input into player.last input. So we're going to go substitute self.last input with self.player.last input, and then we'll be able to actually render that field so that we can actually see what we're doing here. So if we go run that, our last input, see, look at our last input is just only down. Okay. This is so jacked. It doesn't even make sense. Okay, this is not making sense. I think since we initialize it like this, every time, well, no, we should only be initting that once. So I actually don't know why. Let's put nil in here and see if we in fact crash. We don't. Okay. Okay, this is so jacked. So if it was pressed. Okay, I think I don't want to put these in else if statements, because if we have multiple inputs, then it's overriding it. So we want these all to be their own if statement. I think that's part of the problem. And then, let's see. Nope, we're still not getting what we've got up and... Okay. It looks like it only does it when we put multiple inputs. It handles it. But why would that be the case? Because we're just checking the last input here. This is so bad. Yeah, if we hold more than one input, it knows what the last input is. So where are we messing that up? Gosh, I'm so tired, I can't even keep my eyes open. I don't get why it only works with multiple inputs. I'm kind of curious. If we put in the keys pressed instead of this was pressed. Love.keyboard.keys pressed. And let's see if that changes anything. Maybe it was a lowercase keys pressed. Was pressed. Okay. So Love has a default function called love.keyboard.keyspressed that gets populated with a key value for whatever key was pressed. Okay, no, I'm not understanding this. We had Okay. Okay, well, let's try was pressed, and then if that's not it either, then we'll just rethink what we're doing. So we'll go substitute keys with was. I always do that. I exit out instead of saving it. Substitute keys for was. Okay. That's weird. Okay, so we're still getting that same problem. Like, see, look at that. Like, I'm holding all the keys down except lifting up on left. Well, I guess that is technically right for the last input, but we shouldn't ever get nil once if keys are held down, we shouldn't have a last input nil. So I'm not sure what's happening there. I'm curious if we just don't initialize this, if it'll let us see that what is going on where the multiple inputs, it only gets populated for multiple inputs. I don't get it. We're changing it based on if it is down. Let's see how we did it. Oh, not what I wanted. If we see how we did it in our player class before we deleted it, we have a last input that we're getting a string, and then if it was pressed, last input gets 1. This is exactly what we did. Last input gets a string. And then we're keeping track of how many inputs are held down. Okay. I don't know why it's not getting our last input correctly. I'm confused. Oh, and you know what? It might have to do with the walk state or the entity state or the idle state. Could you assign each key a plus or minus value where it says the right is +1 and the left is -1? Yeah, so that's essentially exactly what we do. We give how we used to do it was we had a velocity, and our velocity was 1, so that if you hold right, your velocity is +1, and if you hold left, velocity is -1, so it would actually cancel out. But the issue with that is since its velocity is updating and since the button was being pressed, well, and this is the commented out part, so this is how it used to be. We haven't added velocity just yet. We've actually, in our player class here, we've actually got, it's our player walk state. And I think I just figured out why our other thing was messing up. Right here, we've got a player walk speed. So we're modifying our current X position by our current X position plus our walk speed, which acts as our +1 or our -1, like in this case, if it's left, then we're subtracting it. But the problem with that is that if the key is held down, say both held down, we're not moving, but as far as our animation state's concerned, a direction is held down, so it should be a walk left animation, so he'll be sitting there walking even though he's not moving. So that's why we had to add multiple input handling to actually negate any animation that might be going if we hold multiple inputs at once. But you're exactly right on that. That's exactly what we're doing. Okay, so I think the last input might be getting messed up because of the idle state. Because once we're in the walk state, I used to think it was multiple inputs, but it's actually once we're in the walk state. So actually, I think we need to move all this last input logic into our player class. So if we move that into our player update, I think we might have better luck. because we need access to the last input, whether we're in idle state or in walk state. So if we don't hold any inputs, we're in idle state. Any directional inputs is going to be walk state, unless we have those contradicting ones held, in which it needs to go back to idle. But regardless, we need access to this last input if we're in idle or walk state. So I think that's the problem here. What we'll do is we'll go into our player class here, and in our update function, and we're updating based on our entity, but we also need to just update our player here. Now, I think we might have to update our entity here, because we don't have, I guess, no, I'm curious if this would modify it. Because we do have a self that we're updating, so we should be able to say self. I think we would get rid of player. I think we would just say, since our self is the player, we would just say our self dot last input gets assigned here, and we would go back to our old okay, maybe not. Oh, I'm looking for this line that we've got deleted, so we'll write that out. We'll put this back in our init, turn it on, and we'll turn it on at our self dot last input, not dot player. Oh god, okay, here we go. Okay, look at the last inputs working now. So we aren't rendering the correct animations, but and you know what? This isn't exactly right. It's right in the sense that, okay, so there's another complexity to this, is that our last input is not being assigned when it's held down for continuous input. So we need to go ahead and do that as well, because if you think about the game detecting the keyboard inputs, if the button is held down, the was pressed function won't know it was pressed, because that gets flushed at the end of every frame. So if it is down, you have to check for the continuous input to see if it is still down, not if it was just pressed on the last frame. So we have to update our last. How do we do that? Yeah, we'd have to update our last input based on if it's held down as well. And then we check for anything that was pressed. See, and then the order really matters there, what order we assign that stuff. We'll go to our player walk state now, and actually this is in our player class, because we are changing our animation based on our last input here, but our last input isn't working, so therefore our animations aren't working. So we want to do, I think, in our player state here, our class, we also want to do this if the keyboard is down. If the corresponding keyboard is down, we also want to have a last input. Oh, and you know what? We can't do it here. We can't do it here. We've got to separate it out. We've got to separate it out, because it can't ask for continuous input if this was not pressed. So we have to make sure we do it outside of that. So we'll just go love.keyboard.isDown, and then we'll check if our left is held down, and if that's the case, then our last input is set to be equal to the string left. Yeah, I really like Lua. It's just so straightforward. It really helps, because game dev is so tough. You kind of need all the help you can get, and it's been really nice to me in creating stuff and kind of just letting me do my stuff. So like, instead of using Unity or something like that, you still get to like program everything yourself. You don't use as much visual scripting or anything or interface like you do in Unity or Godot or whatever. So I like that about Lua, because I can just kind of, it's all it is code. So I have to be able to express myself in just code. But the syntax is so nice that it makes it easy. Okay, so now I'm hoping that once we're done with this, our last input will be functioning correctly, but it does matter. The order that we do these things kind of gives precedence to the last thing we code. So we might want to do that very intentionally. But we'll see how it messes up before we decide if we need to change it. Nice, okay. See, look, right here, we hold right and then we're pressing left. Our last input direction should be left. So, and the thing is, you know what? Oh, well, geez, man, it's not quite right. Okay. See, like right there, our last input, or our direction is functioning like we want our last input to be functioning, but it doesn't always do that. Like, if it's, well, see, like right there, holding two directions and then pressing the other, and left works, but right doesn't work, and that has to do with the order we're doing this. Okay, so I think we're going about this all wrong. I think anytime we press a button, we need to populate a string with that button, which we are doing. So it's just a question of how do we handle it when multiple things are down. So I'm gonna take a look at how we did it, how we used to do it here, and see if it illuminates anything, because we already, oh God, we did some nasty ass shit here. Oh, I don't even want to look at that. We literally had to do this like inputs held down and keep track of it, so. Wow. Yeah, this is not so great. So like we're controlling our direction based on what button is down, but then we ask for continuous input to be input into a variable called inputs held down. We get our last input by our was pressed, not by our is down. But then in our multiple input handling, if more than one is down, then we go ahead and ensure that only two are held down, and then we set our last. Well, see, and that wouldn't fix our issue of the order of operations for our things being held down. I don't know what the best way to do this is, because we're just overriding things depending on what keys are held down last. So it's like we need okay, because the secret is when we lift up a key, our is down function doesn't know that it was pressed, so we don't know how to change our last input to be that direction. Because our last input is right, but it's not becoming left when we press it. But if we do it this way, it does turn right, but that's the issue. We need it to work on all directions and for all combinations of inputs here, so that we're overriding it with the correct directions that we want. And this makes me understand why they had it in their game with just one key being pressed. Like, you can only do one direction at a time, but we need diagonal movement. We just need it. So let's go ahead and just sit here and do the hard coding for, not the hard coding, we'll do the multiple input handling here. So we want to check for continuous input. So actually, before we delete that, we want to check for continuous input. So we'll give ourselves a field called inputs held. We get it initialized to 0. Now we check for continuous input, and then we say that inputs held gets to be its current value plus 1. And that's one thing I miss in Lua, or that I wish Lua had, was the plus plus. I really like plus plus incrementation instead of assigning it, typing the same thing twice, when I could just type in a plus plus. So much easier. So that's my big gripe with Lua. That's that and indexing a nil value, and it crashes every 2 seconds, but that's mostly my fault, not Lua's fault. So we're going to go ahead and inputs held gets to be inputs held plus 1. Now there's one more step in this, which is to flush inputs held right here at the beginning, because we don't want to keep incrementing inputs held. It's going to be a maximum of 4 with the 4 directions here. So we also want to print this up to make sure it seems to be working. So we'll go print up, and we print it up. I think we print stuff up in our scene here. So we'll go ahead and print up our inputs held, and we'll put in our player.inputs held here, and we'll put it 5 or 10 pixels below our last debug. So now we need to change this to inputs held, and then there we go. So pressing 1 key yields 1, pressing none yields 0, pressing 2 yields 2, pressing 3 yields 3, and then pressing all 4 yields 4. Okay, so now that we have this, we can kind of tailor our response to the last direction based on how many inputs are held. Because if we limit it to how many inputs are held, then we can ask, okay, was the last input left or what? Like we can, I think the problem is, let's see here, inputs held. So look, we check for, we get the number of inputs held here. Okay, so and here we set our facing direction to be, we're changing our walking direction boolean, but now it's just a player dot direction. So I think we want to modify, I guess we need to modify our last input. Well, let's see, because we're not actually doing anything with our last input at the moment. We're just trying to, last input is just the variable we're trying to get to modify our direction. So yeah, so I guess at the end of the day, by the time we're done with this last input, we would change every last input reference to just self.direction. And if last input works as appropriate, then our direction should work. No, that's not true, because we want our direction. It depends, because our direction used to be modifying our actual moving direction, not the animation that's being played. So we get to decide how to differentiate when we change the animation. And we're doing that based on the last input, not based on the direction. So we can't just replace that with direction, because the direction could be one way, and when we have multiple inputs, our direction is jacked up. So we would need to change this with our multiple inputs. We don't get direction anymore. We would just modify our X and Y position based on our upwards and sidewards, our vertical and horizontal velocity. So, okay, so we've still got quite a bit to do. So what we can do, we just want to make sure our last inputs is working correctly. So let's go ahead to our walk state, and we will go, and actually it's in our player class. Okay, so our inputs held is working as expected. So we're going to make sure that our last input is correct here. So we're going to ask if multiple, we'll call this conflicting input handling, and we'll ask if love.keyboard.isDown left and love.keyboard dot is down right. Okay. And then we need to ask if our inputs held is only 2. Okay, so this is getting, I don't like how we're going about this. There's a better way to do this. The problem is we're trying to get the last input, which would become whatever is down if we release a second button. So if it is down, our last input should be that thing. Okay, so what I really don't get is how come if we have, so why isn't our last input becoming left once we press left? It should become left once we press that. I think we might need to check the was pressed after the is down, because we want the was pressed to overwrite our is down. So it's working only on the very frame. I don't know if you guys can see that. It only turns left on that very frame, not is down. So and left works as expected. This is just that order of operations problem. So there's got to be a better way to fix this. Okay, so the problem is when multiple inputs are being held, the is down is overriding the last input. So we don't necessarily want the last input to be assigned to the corresponding key that is down, but we do want to do it if only one input is held. So maybe we start with that, and then we only, so anytime we're assigning our last input in our is down function, we only do this if the inputs held is just 1. So only if it's equal to 1. If we increment it and then it becomes equal to 2, we don't want to be doing the last input assignment, because we would be overriding a previous last input. I'm not sure if that makes any sense. Let's say we only want, if self inputs held is equal to 1, that's when we would want to assign the last input. So what that would mean is if 2 inputs are held down, then this left is down won't count as a last input. I think that makes sense. We're just trying to get this value to be right. Okay. Okay, if our self, and this is inputs held, not inputs held is equal to 1, then go ahead inputs. Okay. We want to increment it first, and then we want to check if that's the only one held down. Then go ahead and assign us to be equal to that last input. So let's see now. Okay, yeah, last input is functioning correctly for multiple inputs. Oh, not for this direction. Okay, well, let me try that again. Well, I guess we were only doing that for one input. That one works, and then that one doesn't work. Man, what are we doing wrong? Last input is the wrong way to think about it. Like, we want to just decide what input overwrites the others, and that depends on, it's difficult because whether something was pressed or whether something is down is registered differently in the game engine. So something like that works, but the opposite direction doesn't work. So that direction works and that direction works, but we can't get the other to work because this one is overriding it. So how do we want to decide this? Like, I guess we can continue our thing. Like, I'm not sure this helps us, but I guess it does help us. Because we can come in here and say maybe else if there's 2 inputs being held. See, and then it's just messy. It's just messy. How would we do this? We already figured it out once, but I don't like the way we did it last time. And this is the way we did it last time, is we keep track of how many inputs are being held. Yeah, I mean, I'm gonna get rid of the inputs held. We're gonna see. Yeah, no, we need something like the inputs held because. Okay, I think I got it. I mean, it's the same way we did it last time, but we increment our inputs held if it is down no matter what. So that is working right. Our inputs held is working right. But hear me out here. If we go if our inputs held is equal to 2, then we're gonna ask, well, since left would be down and inputs held is 2, that means that left is the direction that's held after. Is that right? Because inputs held 2, left would be the overriding one. But then that's the same as just assigning it to left in the first place. So, wow, I wish I was better at programming, so you guys didn't have to suffer through this. But how do we do it? Because it's like if we have one input and then we hold up we want up to overwrite the left. So if the number of inputs held is 1, and then we hold a second direction, then if inputs held, if the button is pressed and inputs held is already 1 and it becomes 2, then we want to become that second direction. So I think we might be on the right track with this, like because this would be left. Self.inputs held being equal to 2 would mean that left was being pressed after something was already pressed. So we would want to say that our last input gets overridden here to be left, because our last input would be something like right, which would have been our first input held. So let's continue this process of saying else if self.inputs held is equal to 2, that means right would be the second input after a separate different input. So we would want to overwrite. Now it looks like this is that we would just assign it the direction here once and not ask whether or not inputs are held and then call it a day, but that's not the case because these things overwrite one another because we're asking all these directions. And if anything was pressed or is down, it'll overwrite it. But we only want to overwrite it if the certain amount of keys are held down, because that's how we determine what was pressed after another button. So that's just the way we're doing it. I'm sure there's a better way, but let's see if this even gets the job done. Yeah, because putting these in there kind of helps defer that overriding process, because it's asking how many inputs are being held before it determines what direction to actually put our last input as. I don't know if that'll work though, but we'll see. Okay, so we've got inputs held 2 now for all the is down continuous input functions, and we're missing a something somewhere. Okay. See? Well, that's actually working. Well, no, it's not working. If left is down and it's the second input, which is inputs held down 2, left is down, inputs down 2, our last input should be overridden to left, which left is down, inputs held is 2, our last input should be overridden to left, and it's not. Okay. Self.inputs held, okay. I don't know what to do. Is this, like, especially tragic because we already figured this out once? And then the way I'm going about it is the same way I went about it back then, but I don't like this method. And it's not working at the moment. Okay. Let's see if breaking those out has anything to do with it. Yep, our last input should be the correct value, and it's just not. Okay. Well, I wish today was a little more successful, but maybe we just have to rethink this because this is just not working. I don't like the way this is working, so there's got to be a better way. if anytime a key is pressed or a key is down, we insert it into a table, and this table is like a list of the order of in which the keys were pressed. So like if we hold left, down, right, up, it would hold left, down, right, up in indexes 1, 2, 3, 4. Then anytime we release a key, we need to take that out of the table. So we would need a key released function to keep track of that. Then we literally just index at the index of the number of inputs that are in our current inputs held. And then whatever value that is, we assign into our last input. That's the way to do it. So we do need a was released function, just like we've got a was pressed function. So I think there's a way that Lua does that. I think it is, we call love2d was released or something. We can see what that is. Key, it's like keyboard, or key dot was released, something like that. Key released. It's literally love key released key. So what happens is anytime a key is released, you can check that key for it being released and do something based upon it. So I like to store these things into a table so we have access to it. So that's what we were doing here in our main. We've got a keyboard was pressed, and it takes in that key of keys pressed. But we should be inserting this into, see, we're flushing this keys pressed. Okay, see, this is different than I thought it was. We have a keys pressed, but we're not actually okay, so I think, okay, this is confusing me a little because I thought this was different. So this love.keyboard.keys pressed, that is a function that comes with Lua, and it'll be populated to with a key. Okay, gosh. See, because the thing is, we're not using this key pressed function anywhere. We're not using this key pressed. We only do this keys pressed. Right? Like, well, that's how we escape. So key pressed. Okay, I'm a little confused here. Let me take a look. I want to take a look at our Joust repo real quick and make sure that I'm not going crazy here. Yeah, let me take a look in our main for our keys pressed. Okay, so look, we do a similar thing in Joust here where we have a keys released table. Now, okay, so this function, this was pressed and was released, this is weird to me. I don't understand what this is actually doing. We flush our tables there, but I don't even see where we populate them, and we populate them here, like by returning something. That doesn't make any sense to me. We can just go for it, but don't like that we don't. You know what? I think this is the love function. Let me see if love 2D keys pressed, is that the function? It is just key pressed. Yeah. So that's the function that Lua has. So once, like, let's say we press escape. Once we press escape, this love.keyPressed escape gets called, essentially. So what we're doing, we're saying if that key of that love key press function that gets populated automatically is equal to escape, then we go ahead and quit. But then we're going a step further than that, and we're putting a value of true into a key pressed table at index of that key, and we're saying it's true, so that we can ask if love.keyPressed then do something as like a boolean. But we want to do something different in our new game here. We want to actually store the value into the table of what keys are currently held down. So we don't want a keys pressed boolean like we are doing here. We want a keys is down table that holds a table of all the keys that were pressed. So we do want to do something a little different, I think. But we do need a key was released, which looks like key released instead of key pressed. And it's the same deal. It gets populated automatically with that key. So we need to remove the key of that value from our keys currently held down table if we want to remove it. So let's go back here. I think this can work. So we're going to go attach to our session again. Now we don't want, and you know what? We do want a key released just like this, for the simple reason of being able to ask a little boolean if love.down was released, then go ahead and remove it from that table. So we can have a love key released, and we would say that the love.keyboard, yeah, and we can do, we'll put it into the same, we're like essentially adding a field to our love.keyboard, and we're adding a was released key was released. And we're actually, no, yeah, we do want to say was released. And then we pass in the key that was called when we released that key. And we're going to assign that value in our table to be true, so that we could do something specifically if a key was released. And then, so key was released, and then we need to flush. We need to basically, this is in our init function, so this would be our keyboard.key was, actually let's just do key released. We're setting it to an equal table. Now this is in the love.load, so this won't clear it. This will okay, so this is where they're actually using the keys pressed table that they just populated here, and they're asking again, they're just like deferring the keys pressed to a was pressed, I guess, as a semantic kind of thing. it's easier to say, hey, was love.keyboard was pressed key is just a little more semantically clear than keys pressed key. But then we're also changing it to a false if it wasn't the case. If it wasn't held down, it's a false, because right here is just we're saying that the key in our key released table at the index of the key that was populated when we released it becomes true for that frame. And then we're going to say that we've got two functions, a was pressed and a love.keyboard.was released. Now, we pass in that key and it'll be auto-populated with the key that was released. And then we're going to modify our key released. And yeah, it should be a keys released because there's going to be more than one, potentially. So we'll just make sure that this is keys released. This is keys released. This is keys released. And this is where we do the Boolean. So we say this will return true if that key was in fact released on that frame, and return false if not. Okay, so that just gives us a Boolean value to ask, hey, was this released on this previous frame? As long as we flush it in our update, because the default function love gives you for it is just a value that populates. So we need to be able to add that value into a table so that we can ask, hey, were these things released or pressed? And then we need to flush it. So we'll go love.keyboard.keys released, and keys released gets an empty table. So now we should have a keys released function. Now, okay, so here's the fun part. Now in our player state, anytime a button was pressed, we add it to our table of inputs held. Now, right now, inputs held is a number of inputs being held, but we need a global table. So we can call, and we'll put the global table here for now, but we'll call it just input list. And input list gets an empty table. Now, anytime we don't want to do the is down, we want to do on the was pressed. And what we can say is, we can say if left was pressed, then we are going to insert, we're going to table.insert. Now this function takes in two values. It takes in a list, which is our input list, and it takes in a value, which is the value of a string called left. We're going to insert that into the table. But we only want to do that, and actually, yeah, we only want to do that if left isn't in that input list, which it can only happen once. So if since was pressed only happens once, it's not the continuous input, it should be inserted only once, and as long as we flush it upon a was released, then it should be correct there. So what I'm going to do here is just quickly take all of our other values, and anytime any of those things were pressed, we're going to just change the word to be that appropriate. What we're inserting is the string of the appropriate input that's held down, and then we need to go ahead and ask if the love.keyboard was released on the key. so that we can take that value out. Now this is the tricky part because we can't, and actually, you know, we might luck out here because instead of taking away, we want was released, and we're asking the direction that was released on this previous frame. And if left was released, that implies that left was at least was pressed or is down. And if it at least, yeah, so like upon release, we need a table.remove, and that takes in a list and a position. So this is tricky because we don't know what position in the table this value is. So it's almost like we need a position. So we're gonna say local position gets 0, and then we're gonna cycle through all of our, or I gets 1, because Lua is 1 indexed, for the number of values in our input list. We're gonna do something, and the do something is, what am I missing here? Oh, we need the increment. So we put in a 1. So we're gonna do something, a list input amount of times, and if we want to assign the position if the value, so the key, yeah, we need to cycle through. Oh, we got to do for the key comma value. So we can say position for the key in the position comma input list. That isn't exactly right. What do we, key value, and then cycle through. What are we missing here? Because we want the index, we want to grab the index of the input list that is equal to the string that is up here. So we need to cycle through our input list with access to the index. I think we don't need to do number there. Okay. Let me, for k possession. Oh, in pairs. We got to do in pairs. In pairs of input list. So that's, no, in pairs. We're close. It's something like this. Let me see, it is love 2D cycle. This is basic stuff. I should know how to do this by now. Table in pairs. For key value in pairs, do something. So for key value in pairs, that's what we did in pairs. For key value, oh, no comma here. Oh my God, okay. No comma there. So we can say for key value in pairs of input list, do something, and we're checking if the position, which is the value, if the position is equal to the string that is left, then we want to assign our position to get this position value, which would be we actually want the index. So what we can do is say if the key, no. Okay, so yeah, we do want to check the position here, and then we want to assign the key into our, so to be verbose about this, we'll say our index, and then we'll say local index gets, if the position, which is the value in this list, is equal to the string left, then we're going to assign the k into our index, because the k is the index of our iterator here, and we're putting that iterator into our index variable, and then we can table.remove the value. Actually, yeah, we pass in the list first, so input list, and then we pass in the position, which is then index. So if left was released, we do have the string left in our input list if we did the above correct. So then whatever index left is in our input list, we're going to save that as an index, and then we're going to remove that index from our input list. And that's just for one direction there. But I want to be able to say, like, we should loop through our input list and print all those values on screen here, so that we can make sure that we're doing this correctly. In our scene, we will go to where we're rendering stuff, and we'll do we're going to go through those tables. So we want for key value in pairs of input list, do something, and the do something is we're going to print every one of those things. So we're going to print index, and then we're going to print the number, which is going to be the key. So we're going to concatenate our key into a string. So it'll be like index 1 is equal to, so we're going to concatenate another equal to, and then we're going to say is equal to the value of that list. So then we're going to string the actual value of that list, and then we're going to go at our 5, and we've got to modify this. So what we'll do is we'll say 25 plus our key times 10. So each line will be 10 pixels lower on the y-axis, because the first argument here is x of 5, and then this will be, and we're doing 25 is the base start, and then on key 1 it'll be times 10, so plus 10. So everyone should be 10 lower. So let's see if we've got our input list going, and we got a wrong thing here. Oh, we've got to concatenate this string as well. Okay, 109. So a string, concatenate to string, concatenate to this string, concatenate to this string. Okay. Look at this. We've got... I've never seen this before. We don't want... we're literally calling print, which prints to our terminal, but we want to print onto our screen. So love.graphics.print, which I've never made that mistake before. I'm surprised, but that was kind of cool. Okay. Oh, yes. Okay. Yes. So look, once we release the left button, our index gets removed. So right now, that's only the last button, but that's working correct, because look, inputs index 1 is left, we let go, no index, no inputs held. Maybe what we can do is, if there's no, we're getting too ahead of ourselves. We can just, that's good enough for me to say that this is working as expected. So we can go ahead and finish our logic here, and we can say that where are we? We were in our player class. Okay, so we need to do this for every was released, so that we flush every value from our input list upon that key being pressed. So what we can do, we've got left, now we need right. So we'll go if right was pressed, as long as this was equal to right, and we can do this even better. We can say we're going to change, we're going to substitute, I already messed up. We're going to substitute left with right, no, up. and then we need down. So we're going to go ahead, select these. We're going to substitute left with down, and then we're going to see our lists. If one is held, we've only got one index in our input table. If two things are held, we've got them both in there, and they get put. See how left is the second index there? But if I start with left, holding right is the second index. So we are removing them at the correct indexes, and we're only inputting them and only having them in our inputs held table if the key is currently down. So what that gives us now is whatever the last button we press, it's the highest index of precedence. So the last thing we press, so like let's say up is the last button we press. So left, down, right, up. The last index 4 of our total index list is up. That becomes what we were saying our last input was. So now that we've got that, we can save last input as the highest value of our input list. And it's not the highest value, it's the value of how many things are in an input list. So if there's 4, we want the 4th. If there's 3, we want the 3rd. If there's 1, we just want the 1. So now we're going to go put in our last input. Now instead of our old nasty last input, let me see, where do we do it? Here. Instead of doing this, instead of doing our inputs held, we don't actually have to do this anymore because we actually do this. We're doing this for our inputs table, and that's global. So we can just get rid of all this crap. We don't need to do any of this. Actually, yeah, we need to do this because this is where we're actually inserting into our input list upon those presses. But we don't need this last input anymore. I'm gonna just comment this out. Oh, yeah, just comment this out. And then, so there's, okay, so let's leave us a little note here that says, this is populate our input list. And then this is remove values from input list upon release. And then now that we've got those, we shouldn't need to check our multiple input handling, but what we do need to do is after we've inputted and released all our input lists, we need to get the value that's at the number of input lists. So this hashtag is the number of items in the input list, and then we're going to go ahead and set our last input, which it's a self.last input. So we're going to say self.last input is now going to get we want, and this is going to look a little weird, we want to assign the input list at the value at the index of the number of values that are in our input list. But this, it's not parentheses, it's brackets. So we're saying go to our input list at the index of the number of items in our input list. So that'll be our last input, and assign that into our self.last input. So now if we go into our player class here and we go see, stop recording, we'll go into, okay, what am I doing? We want to go into the scene, and we want to make sure we're rendering our last input, which is now our new last input. I'm going to just make this all caps so I know that this is our new one. And we are putting in our player last input. Okay, let's see if our last input is now correct. So last input is down, up. Okay, that's correct. Right, left. Okay, that's correct. That's all correct. Up, yep, up, yep. Down, yep, down. That's all correct. Okay, so now we've got our last input actually working. So now what we can do is go ahead We still haven't got diagonal movement after all of today, but we've got our last input correct, which means that our direction at least is correct. So see how if he walks left, he goes and turns left. And if he backtracks, oh crap, we don't have our backtrack. Let me see if we've got in our player class when we're going to change, and this might be in our walk update. Yeah, I think it's in our player walk state. If the last input is right, we're gonna change to walk right. Okay, this isn't right. We don't need to check for the continuous input. We can just ask. Yeah, we don't need to check for this. And actually, shit. We shouldn't need to check for the button being pressed for it to change animation. If our direction, no, if our last input, I guess it depends how we do it. It depends how we want to handle our multiple inputs. But I don't like that left isn't working. Let me test up and down. So if we walk down and hold up, the up overwrites the down, which is correct. But if we walk up and then press down, we get our last input equal to down, which is correct, but we're not changing our animation. So why aren't we changing our animation? Because if up was down and then down was down, we should be walk down. Okay. I think what I want to do is take out all references to changing the player animation here. And I actually want to change it when we do our last input, because once we do our last input assignment here in our, where was it? Player class? Yep. So if, I think we want to do it something like this. Like we want to also assign our animation to be whatever the last input is. Okay, so if instead of left, up, and down, we actually give the name of our change animation state, then we can go ahead and change our animation state to be our last input right here. So we could put, oopsie. The idea here is to highlight whatever in here. Nope. VI parentheses. And then we want to change with the self dot last input. So we're going to be changing our animation state to be equal to the string that's our last input, and that means that we need to change this to be the name of the animation of the thing we want. No. We want to insert. Okay, where do we insert it? When we insert it, the thing we want to insert is the direction here. Walk left, walk right, and then walk up and walk down. So those are now the strings that are in our input list. And then if the position is equal to the walk left string or the walk right string or the walk up string, okay, or the walk down, then we remove it, and then we should be able to change our player animation based on the last input. So now let's see if that's player is a nil value. Let me go to our player and, well, self.player. Oh, we are the player, so it's just a self change animation. Entity idle state, local anim. Oh gosh. We must have this wrong. If there is a self.lastInput, then we're going to go ahead and change it to that. Oops. And then we say else self. Do we do idle here? Let's just try to get it to stop crashing, and we'll just put idle. Dude, okay, player 40, okay, we just need to fix that. Player 40, function line 15 in our player. What is line 15? Oh, we just are missing an end somewhere. Oh. Okay. Now I want to go into our entity walk state, and I want to say that we don't change our animation anymore based on the direction, which is where. Okay, we don't want to change this animation. And you know what? Yeah, this self.entity change animation, and the self.entity is the player, I guess. Oh, this might not work. No, this isn't where we want it. We want it in our player walk state. Okay, this is where we want to mute these change animations. And then we'll see, I just want to change our animation to be whatever our last input is. We've got the last input working, and we've got the change state to idle. Okay. Dude. Okay, entity idle state is crashing. So I think we don't need, in our player class, to change it to idle. Because animation isn't idle, the state is. So we couldn't do that anyway. Yes, that's looking right. That's looking right. I mean, it's jacked in the sense that the X and Y positions aren't working, but it's right in the sense that our last input is now overriding. So in our game, if we walk up then left, he's going to walk diagonal but face left. So that's right. That's right. That's right. That's right. That's right. That's right. And that's right. So all our directions are now correct. Now we just need to have the correct vertical and horizontal velocity. So this is great. This is a great spot to leave us for tomorrow. So we've got our last inputs fixed, and it's a lot prettier than we used to have it. So I'm glad we did that. We've got our last inputs working better, and we are changing our state machine based on our last input, which changes the render based on whatever last input is held. So next we need to change our actual direction based on what's currently held, unless we've got, two directly conflicting directions being held, in which we need to not do anything and change it to our idle. But this is really good. And then we need to ultimately add back in our collision detection to change our maps and to move. So that's going to be tomorrow. That was good that we didn't quit and we did this. I'm going to clean up the player class real quick before we commit, so we don't have any unnecessary stuff. And then we'll call it a night. Yeah, we ultimately, actually, and I'll leave this, we do want conflicting input handling, so I'll leave it here. And then, oh, yuck. Okay, yeah, that's our old code. I'm gonna leave that for now. I do like that we figured out a better way to do the last input. I'm happy with that. Let's just make sure our walk state is cleaned up, which we've got to remove all this nasty stuff. So like we're currently still updating our X and Y based on our direction, not based on the inputs being held down. So we need to change that. We'll just say work on this next. And then we don't need to do that. I don't know all the negatives of taking our player walk state out of inheriting the entity walk state. We are trying to do different things than the normal entity walk states, so I guess it makes sense because the entity walk states aren't going to do anything with the left keyboard or the arrow key keyboard inputs, so I think that's okay. And then we want that's pretty clean. Let's go check out our git diff here, and we'll see that we've got a key released function now that populates a table with keys released values. We've got an input list that holds a string of any input that we are holding down on the keyboard, on the arrow keys. We've got animation being based on that last input of our input list. Then we've got some debugging. We got some changes to our player walk state, which no longer inherits our entity walk state. And instead, we take out our change animations and we move it into our, and this, we don't actually have all the files here, because if we do a get status, we'll see that we've got one untracked, which is a, don't we have a untracked? Oh no, we put it, okay, we put it in our player walk state. Okay, so we moved our entity walk state to, our player walk state no longer inherits the entity walk state. Okay, so we'll get add a commit saying change player's animation state based on last input held. Okay, and then tomorrow we're going to be doing the actual velocity, X and Y velocity. Now that we've got the correct animations working, and then once we got the velocity working, the diagonals working, we normalize our vectors, then that's done, and then we go back to our edge detection where we go and then trigger the scene transition so that we can walk through the map. So we're doing good. And then at that point, we'll be back to where we were with our old system, just this time it's so much more clean. And then we can start adding entities of geckos, spiders, ghosts, whatever we want to add into our game. We've now got an entity class to kind of handle all that stuff. So that should be really nice. That's it for tonight. I'll be back tomorrow around 7. Leba, if you're still here watching, I appreciate you. Thanks. I hope you liked it. I'll catch you all tomorrow, but thanks for watching.